Hi guys, my name is Gino Leon and I'm studying renewable energy at the University of Exeter. This video was created for my second year engineering for energy professional assignment. It aims to provide a solid understanding on the importance of having a factor of safety in engineering. Before we jump straight away into technical sides of things, ask yourselves this question: why do materials or structures fail? We have seen catastrophic failures from the past, such as bridge failures, dam failures, wind turbine failures, and the list goes on and on and on. One of the most fundamental jobs of an engineer is to ensure that the strength of materials are always greater than the operating load. One important value used precisely for these calculations is the factor of safety, which will be the focus of today's video.
So, what is factor of safety?
Factor of safety is simply the ratio between the strength of materials to the expected load. Its value must always be greater than 1 for a safe design. Most factor of safety ranges from 1 to 10. Before calculating the factor of safety, these considerations must always be included. If the factor of safety is too small, the likelihood of failure increases. This is not acceptable. However, if the factor of safety is too large, it's referred to as over-engineering. This means that the materials are wasted and more money is spent. Engineers therefore has to ensure a high level of safety without spending too much. Typically, factor of safety for most designs are industry standards, and these are some typical values. There are 3 important parameters which are used to determine the allowable stress and calculate the factor of safety: the yield stress, the ultimate tensile stress, and the shear stress. In brittle materials, for example, the strength used to calculate the factor of safety is the ultimate stress of brittle. As soon as the ultimate stress gets exceeded, the material will fail. Therefore, we can use the ultimate tensile stress if the material is subjected to tension, the ultimate compressive stress if the material is subjected to compression, or the ultimate shear stress if the material is subjected to shear forces. Therefore, the ultimate stress of concrete is used to calculate the factor of safety for foundations of wind turbines, buildings, or any other concrete structures. Ultimate stress can also be used in materials with unidentified yield stress, such as wood. For ductile materials, the allowable stress will be determined by the yield stress. For most designs, we want them to stay in the elastic region and avoid permanent deformation. Therefore, we can use the yield stress to determine a safe operating load. In some cases, materials are allowed to deform as its impact might not necessarily be substantial, so we can use their ultimate stress. This explains why in some designs there are safe working load and maximum working load. The type of stress will depend on the force subjected during operation. Do note, however, that there are cases that the stresses are not constant as the force and areas can vary. Just take a wind turbine blade for example. The area of the blade differs and the force is not uniform as speed increases with height. This requires some more complex analysis which goes beyond the scope of this video, unfortunately. So, why do we need to know about factor of safety? Even if engineers are amongst the most intelligent people there are, they are not psychics. Therefore, they cannot predict the actual load that their design will be subjected to during operation. This is attributed to uncertainties in load estimates and unforeseen circumstances as mentioned. Therefore, My take-home message for you guys is that if there are uncertainties in node estimates, the higher the factor of safety will be, and the lower the uncertainty, the lower the factor of safety. Just remember this, and we will minimize structural failures. Thank you for paying attention, and see you.